video will demonstrate how to fabricate a laminated socket for all distal puck systems. Be sure not to use carbon fiber in your socket fabrication. Carbon fiber creates a Faraday cage effect and will block the Bluetooth signal on the Smart Puck and the Zero Puck SP. Begin by using a 16 by 16, 3/16 inch thick sheet of PETG plastic. Ensure there is an air source that runs through the model to the dummy. Blister form the plastic over the model and the dummy. Twist the frame as the plastic is pulled down over the model. Ensure that the plastic is glass smooth in the sealing area or the red zone where the puck seal will reside. Use a hot awl to burn out the 5-hole pattern in the bottom of the socket. If you do not wish to use the center post in the lamination plate, do not burn out the center hole in the bottom of the socket. Use Dow Corning insulating compound, wax, or something similar to prevent resin from entering the bottom of the socket during the lamination process. If you would prefer to use an airtight resin and a PVA bag instead of the PETG inner, be sure you install the cap screws on the exterior of the PVA bag. This will prevent webbing of the socket material. Install the cap screws into the bottom of the socket. Ensure that the cap screws are installed on the outside of the PETG plastic. The screws should be level. If necessary, you can extend the screws to increase the socket thickness. If you would like to use the fabrication dots, begin by bisecting 2 of the cap screws. Extend that line up the puck body 1/2 inch. Use the end of the 1/2 inch line to act as a center point access to draw a 3/4 inch circle. This will be where you'll place the first dot. Ensure that the dot is not placed right on the floor of the socket. There are 2 fabrication dots that come in your kit, a round one for the charge port and a rectangular one for the vapor puck valves. Affix the dot to your socket. Ensure it's firmly attached. This will create a grind-through surface after fabrication. The dots are completely optional. Assess the distal socket thickness by placing the lamination plate on the cap screws. If an increased thickness is desired, back out the cap screws. Ensure all screws are even. Thread in the center post, and we are now ready to begin the lamination process. Sand the outer surface of the PETG. In this demonstration, we will not use the fabrication dots. We prefer to use tooling to drill out the charge port hole in the socket after the fact. We'll utilize a 3/4 inch drill bit once the tooling and the model have been extracted. If you do not want to use the center post and would prefer to grind down to the cap screws, do not burn out the center hole in the PETG on the bottom of the socket. Apply your desired layup to the model. Make sure you have adequate coverage on the bottom of the puck. It is possible to use carbon tape, but do not completely encase the puck in carbon. After the desired layup is complete on the model, ensure that you have adequate thickness on the bottom of the puck, as you'll be grinding down to the cap screws to create a completely flat surface to mount external componentry to. The center hole will be drilled after the fact. The center hole allows the puck to breathe and to read the outside pressure. To use the center post in the lamination process, lubricate the center post and install it into the center hole of the molding dummy. Apply the layup. Each subsequent layer of the layup will be tied to the post or twisted around the post. Do not use carbon fiber as your socket material. It will block the Bluetooth signal. Use alternates such as Coyote Composite, NSP, or Synthex. Apply the composite to the model and secure it at the proximal end. Pull the composite tight and tie it to the center post at the distal aspect of the model. Also ensure that the proximal aspect of the composite material has been secured to the mold, so the material does not move when the center post is removed. Ensure the distal end has adequate coverage and thickness. Apply finishing material to the model and ensure that your twist around the post is tight. Use scissors to expose the cap screws on the bottom of the model. Tuck the fabric around the screws so the heads are easily visible. You're now ready to remove the center post. Remove the post carefully such that the fabric hole is not distorted around the post, and you will be able to reinsert the center post. Relubricate the center post and the lamination plate to ensure you'll be able to remove them after the lamination. Reinstall the center post with the lamination plate. Ensure the material thickness between the end of the dummy and the lamination plate is adequate. Align the lamination plate with the cap screws. If you did not use a PETG inner on your socket, it will be necessary to use an airtight resin such as FabTech ResTech or ER resin. Apply a PVA bag over the model. Pour the resin into the PVA bag and laminate to complete the socket fabrication process.